Hi friends, welcome back to another session on operating systems. Today let's see what OS debugging is all about. Operating systems are some of the most complex pieces of software ever created and are like all software, they sometimes go wrong. When they do, we need a process called debugging to identify what went wrong with the operating system. OS debugging is not like fixing a regular application. Here you are working deep in the system, often with no graphical interface, no friendly error messages, and sometimes no room for mistakes. It's similar to trying to fix an engine while the car is running at full speed. That's what kernel level debugging feels like. So, how do you think developers actually debug an operating system? First, they use logs to understand what the kernel is doing right before the crash. Next, they might turn to kernel debuggers for remote step-by-step debugging of a running system. When the system crashes entirely, developers analyze crash dumps, snapshots of the memory at the moment of failure to trace the root cause. Think of it as a black box data from an aircraft. So finally, the tools like static analyzers catch bugs in the code before it's even compiled, helping to prevent memory leaks, race conditions, and error. That's a logical errors. Debugging an operating system is equal parts art and science. It's a detective game that requires patience, tools, and deep understanding of how things work beneath the surface. But when you finally find that one line of code that was bringing the system down, it feels like a magic. So let's see what exactly the OS debugging consists of. It's a process of identifying and fixing bugs or the errors in the operating system, including the kernel, drivers, and system calls or the startup process. So this was the various components and what we need to debug. Looking at the kernel, so the kernel may stop working, which we often call crash, may have deadlocks because of the resource problem, maybe because of the memory leak there may be a problem, or there may be bugs in scheduling system. So all this come under the kernel, and any of these go wrong, then the kernel stops working or it crashes. At the device drivers level, there may be incorrect hardware communication or there may be crashes. At the system calls level, it may be unexpected behavior or there may be permission issues. So it may uh, provide or it may allow some user activity to work in the kernel mode, though it was not allowed to do so. That may create a problem. So these may happen due to mistakes at the system call level or at the boot process. So it may hang during the startup or it may miss some of the modules, and the whole operating system is made up of modules, and if some modules are not properly loaded, then some component of the system may not be working, and because of that the whole system fails. So that may happen during the boot process or during the process management. It may be because of the zombie processes. That means the process which was no more active, but still is occupying the memory, and because of such problems the memory is unnecessarily occupied by inactive or dead processes, and not allowing any more new processes to come up because there is no more memory available, or maybe some stuck states where the process may get stuck at some state for some reasons, and that may create a problem, or it may be due to the interrupts and IO activities. So that may be timing issues or non-responsive devices and all that. So these are some of the problems we look at during the operating system debugging at various component levels. Now, the process of debugging, when you say that it may be failure analysis, yes, is the process of identifying, understanding, and resolving the system failures in an operating system or any software running under it. So the process is discover the root cause of crashes or freezes or unexpected behavior, and then make sure that it doesn't recur, so prevent recurrence. Then because of that we have improved system stability, and the system is more reliable. So due to the failure analysis we can understand what are the root causes of the crashes and all that, and then we can prevent this to recur, and by doing so we can improve the system stability and the reliability. Then we have another process called performance tuning. It's a process of analyzing, adjusting, and optimizing a system to ensure it runs more efficiently, quickly, and reliably. By doing this, we improve the user experience because we are optimizing the system, and because of this optimization the system runs more efficiently and more quickly and more reliably, and because of which user experience will be a better one, and it will maximize the hardware utilization and then reduce the latency and the response time. So when we call for some activity, and if that activity can quickly respond back with the answer, with a reliable answer more efficiently, definitely the latency will reduce, response time will reduce, and handle more users and processes concurrently, because there is less latency, response time is fast, so each user can be responded at a faster rate, and because of this in a given time the system can address more number of users and all that, and it prevents the bottlenecks and crashes through the performance tuning. Then we have dtrace, which is a dynamic tracing, is a real-time diagnostic and troubleshooting tool which lets us to observe how the operating system and the applications are behaving under the hood. So this gives a live performance, and it makes live performance tuning without restarting the services. So while the system is running, it just tries to identify anything is going wrong, and it just looks for problems and tries to address them, and this all things happen in the live, and we don't have to stop the service and then restart it. So that's the advantage of dtrace. The system calls are regularly traced, function calls are monitored, Then debugging the kernel level and user level performance issues are regularly done, and bottlenecks, memory leaks, and CPU hogs are regularly identified. And that's all about OS debugging.